So, if we end up with a leading coefficient that is other than 1, then we're going to get rid of it. And the way you get rid of it is just divide it out. Now, of course, when you divide, you're going to have to divide everything. So if I divide this, and this, and this, and this, I'm going to have to divide it all. I'm really just using the distributive property here, guys. Okay? I'm just using it with a fraction 1/2. Okay? So 2, 2, 2, 2. Clean it up. That gives you what we wanted, which was x squared. I don't want to do that. That gives you x squared plus 7 over 2x minus 2 equals 0. Are we okay? Alright. Now, is this trinomial factorable? Maybe. It's kind of a pain with that weirdo looking b, right? So maybe it's factorable, maybe it's not. I could play around with it and figure it out if you wanted to. Or I know for a fact I could complete the square and force it to be a perfect square, right? So let's just do that. Alright, so from here on out, it's just like last night. Complete the square like normal. Let's get rid of the 2. Leaves us with this. Well, I hope I left myself enough room to write here. I'm going to complete the square. Let me get a little help with that. You guys got the calculator. I don't really need it, but let's see, I need to do 7 over 2 divided by 2. Here's a quick little review for you guys. If you're dividing by 2 with fractions from middle school, don't you really multiply by 1/2? So do I need a calculator? No, it's 7/4, right? Alright, and then I square it and you get 49/16 on both sides, right? This is x plus what? 7/4 squared, and that's going to equal, let's see, 2 is really 32 over 16. So does it end up being 81 over 16? Oh, that's great. I love that. Does anybody else like that? Come on, what do you notice immediately? Yeah, they're both perfect squares. This is going to be nice, isn't it? Alright, so I'm going to take the square root of both sides. I've run out of room, of course. So that's going to leave me with, I'm going to have to come over here. That's going to leave me with x plus 7/4 equals plus or minus, what's the square root of 81 over 16 without using your calculator? It's going to be square root of 81 is 9, square root of 16 is 4, it's 9/4. And then finish solving. And that gives you x equals, let's see, I've got negative 7/4 plus 9/4, and I've got it minus 9/4. So what does that give me? Say that again. 4.5. 4 halves? 1/2. Alright. I see the 1/2. And the other one is negative 4. Is that what you're saying? I don't think that's right. It'd be, let's see here. Negative 7 plus 9 is 2, and 2 over 4 is 1/2. So there's the 1/2. Negative 7 minus 9 is negative 16 over 4 is negative 4. I think it's negative 4. Alright. Alright, we'll look at this second example then. And once again, we notice that this trinomial is not factorable. If it were factorable, we would try to handle it a different way. But it's not factorable, so we're thinking that we probably want to complete the square. But of course we do have this ugly 3 out front. On the first example, we went ahead and divided by 2 at the very beginning, and that worked out well, but you can also divide after you subtract the 6 over, or excuse me, add the 6 over. I think because 3 is divisible by 6, I'm going to go ahead and do it now, but it doesn't matter. There's a 5 over here. You know, I'm going to have to deal with a fraction somewhere or another, so it doesn't really matter. So let's go ahead and add the 6. Might as well. 3x squared plus 2x is now going to be equal to 1. And again, I do have to get rid of that leading coefficient, so we're going to divide everything by 3, and I have to do that. I have to do that before I try to complete the square. So that's going to give me x squared plus 2/3 x. I'm going to complete the square here in a minute, so I'm going to leave a little space there. Equals 1/3. And those aren't too bad. I can deal with thirds. Ready to complete the square. So of course in my head I'm looking at that 2/3, and I'm thinking to myself on that 2/3, okay, I need half of 2/3, so that's 2/3 divided by
Garrison Henshaw, please go to Eric Boston's room.
Which of course,
Garrison Henshaw, please go to Eric Boston's
back
room.
to middle school, tells me to multiply by a half, so that equals 2/6, which is 1/3. I have to square the 1/3, and that's going to give me 1/9. So I'll be adding 1/9 to both sides. This, of course, is a perfect square now. That was the whole reason we did what we did. So this is now x plus 1/3 to the second power equals, let's see, I got 1/3 plus 1/9. Let's see what I got here. 1/3 plus 1/9. See, that's really 3/9, right? So that's 4/9. I like 4/9 because I recognize the 4 and 9 are both perfect. So this is going to be pretty nice for me. Now I'm sitting in the same situation that I was the other day. I have a term raised to the second power. So in order to get rid of the square, I'm going to take the square root. So I'm going to take the square root of both sides, and I'm going to move over here to this side and finish this out. That leaves me with x plus 1/3 is equal to, I've got positive and negative because of the square root, and the square root of 4/9 is the same thing as the square root of 4 over the square root of 9. Since they're both perfect, the square root of that's going to be 2/3. Alright, that was nice. Now, if I'm in a situation where this ends up being something that's not perfect, then I would just need to simplify and use my simplest radical form. But since this was perfect, I'm going to go ahead and change it to a nice number. That's 2/3. Finish solving. That's minus 1/3, minus 1/3. They go away. And I'm left with my answer. Should be x equals. Well, I've got negative 1/3. And I'm going to add 2/3 one time. And I'm also going to subtract 2/3 one time. So I end up with two different answers there. And see, I've got negative 1. See, I got common denominators. So negative 1 plus 2 is positive 1, so that's positive 1/3. And I've got negative 1 minus 2, which is negative 3, so that's going to be negative 3 over 3, which is negative 1. So there's my solution. And I guess that's it.